Let's now see how we can extract the valuable parameters of this solar cell. For that, we will choose the third option, which is Lambert W fitting mode. Here you can manually input your current and voltage data of your solar cell and click the plot graph that will start the graph, and you can do further analysis, or you can use these tools to extract the current and voltage data from any image or the curve you have. For example, right now we have these 100 points, so these all are the current and voltage data that we need, so we can start doing the analysis. So I will just simply click plot graph, and it automatically creates the curve from this previous image that we have been extracted the data from. So this is the IV curve that we want to analyze. So the first thing you want to do, you click the analyze parameters, and as you can see, it gives us this fitting curve, but it did not fit well because this is the initial guess. So these values are not accurate yet, so we have to align this green curve perfectly with the red one for exact answers. And here in the parameters, I want to keep the temperature constant at 298. So I will just click here. This means that now the temperature will not change, it will be constant at 298. And to start the fitting, we can use this algorithm that we have. Either use the simplex or the second one, but this one can take longer time. So by default we choose the first one, and it gives the accurate answer most of the time. So you can just simply use the default algorithm. And below is some of the parameters for this algorithm. For example, this one is the max iteration points. This tells you how many times the fitting is gonna apply for better alignment. By default is 500, but you can make it like 1000 as well. This is the tolerance. You can make it like 10 to the power minus 12 to minus 15. Depends on how aligned you want to make, but by default you can just leave it like this. For scale factor, you can also leave it like this, or if your curve is not aligning well, you can just make it 10 to the power minus 3 or minus 2 also. It's up to you how you want to check. This one also you can just keep it as it is, no need to change anything, because this is gonna tell you how much the error is gonna come for all of these parameters value. And the last one is the how many times you wanna check the fitting. For example, if you choose this one iteration at a time, that means when you click the run Lambert W fitting, it will only test the fitting for one time. But if you check for the full, it means it will check for all 500 times that we have here. So once you are satisfied with all these parameters, you can just simply click run Lambert W fitting to start. So you click and you wait a little bit. Okay, as you can see that the fitting is getting closer, and here is all the results that we have with all the error values as well, and the temperature is fixed because we keep it as a constant. So I will again click here for another testing. Okay, now this part is aligned well, but here the alignment is not very well. So I will just increase the iteration points to 1000 maybe. Click Lambert W fit. Okay, still it's the same thing. You can check it by clicking undo the fit. So this is the previous one, and this is the after one, and there is not a big changes. Just to make sure, I will check one last time. Okay, so it's not fitting well in this portion, and it like a stuck, because no matter how many times I'm running the fitting, this part is not changing. That means we should do initialize fit again. So I will click initialize fit, that reset the fitting function. I will again click the initialize parameter, and I will run the fit again. Well, now you can see that the fitting is very accurate. Okay, you can see in the zoom preview that the green curve aligned very well. Here there is a little bit of deviation, but overall it fitted quite well. So uh, when it is aligned very well, that means that I'm satisfied with this result I have. So for example, the shunt resistance um, is 104, and there are like 1.17 error. So it's like 102 or 105. It's up to you, but it's quite accurate because I already know the value of this curve and it's very accurate. Also, the series resistance is very low because this portion is very good, like ideal curve of a solar cell. But this portion is not ideal because for ideal IV curve it should be like this and then it should go this way. So from the graph I already know that the shunt resistance should be very low, and here also we can see the shunt resistance is very low, but the series resistance came very well. So yes, you can get very accurate result from this fitting of your solar cell IV curve. So this is how you can use this tool to extract the valuable data of your solar cell.